Just trying to have fun, so. All right, look at this integral. Integral x cubed times x squared plus 2 to the fifth. U is what? And du. Yep, exactly. So yesterday, looking at integrals, I would say, considering substitution type problems, we did problems kind of level 1 and level 2. Today we're going to look at level 3 and level 4 type substitution problems. Okay? So now that you have that basis solidified and you feel good to go, what we need to do is we need to deal with this. What's the problem? Yeah, exactly. So you recognize, does the 2 cause a problem? Not really. We just go 1 half du is equal to x dx. What you're frustrated by is that you see an x cubed here and not just x. So you would multiply both sides by x squared. Okay, so the problem then is that you get a 1 half x squared du, and the u doesn't match with the x, does it? And that's a big problem. Can't mix variables, folks. Excellent. So Spencer says then this problem is unsolvable, and you're 100% correct that in those situations we do come across some problems that are unsolvable. This is not one though. I am sure. Okay. So just to make Spencer's point, I thought I knew everything about math, and I found out one day I didn't. Teacher walked in front of me, and we were doing integral problems, and I had no problem doing it. My teacher said, "Well," he said, "Kevin, I want you to take this." He said, "Come back on Monday and let me know what you got." I said, okay, big deal. I came back and I gave him an answer, and he said, "You're completely wrong." And no, 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 it didn't work like that. No. Um, this antiderivative is absurd. Trying to compute this is extremely difficult. And there are some antiderivatives when you look at them, you say we're kind of hopeless at this point. Okay. Um, can I show you something really cool to help you appreciate just a little bit of how challenging some of these things are? What's the antiderivative of sine of x? Cosine of x. Okay, negative cosine of x, right? Okay, so we know that. But in order to get around this situation, um, there's a branch of mathematics in calculus 2 where we learn that every single function can be written as a polynomial. So this sine of x is actually x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial. And yes, all the way to an infinite number of terms. The further you carry it out, the better approximation it is. So I know it's incredible when you take the class, you see how they did this. But here's the question. I know the antiderivative of sine is negative cosine, right? You could also express as a polynomial. Could you take the antiderivative of this? You could. So here's the deal. They start taking these things and expressing them first as polynomials, which is challenging enough, and then taking antiderivatives from there, and you just have the approximation. I would be very hard pressed to do that problem. Okay? No. Right. To finish off my point, to show you how cool this is, when you type in sine of 36 degrees in your calculator gives you an answer just like that, doesn't it? How does sine know what the sine of 36 is? How does your calculator know that? It has that formula plugged in for sine and it evaluates it. That's how it does it. It plugs it into that. Which is why when scientific calculators came out, is incredible because they were able to handle computation of that sort. So I'll show you. I'll pull it up when you guys come back from lunch, and you're gonna see kind of a cool example of it. So Spencer's right. Some integrals are just about impossible to evaluate, but we can do this one, and it just involves a little trick. That's all it is. No, you don't just plug in your calculator. What you do is this. What did I do? Yeah, I took the x cubed, I wrote as x squared times x. You guys all good with that? So I'll show you what it does. Okay? 1 over 2 integral, and I put a du. Okay? Everybody good with that step? 1/2 du gets rid of what? X to the dx. Now, 1/2 du gets rid of x and dx. I'm going to get rid of this with what? U to the... Very good. The only thing I have left to get rid of is there's an x squared right on the board. It would, if it was a snake, it would bite you. Does anybody see it? See it? Good job, Jake. Look at that. Is that nice? Because that's what u is. So now I got 1/2 times the integral, right, as a polynomial. I got u to the 6th minus 2u to the 5th du. Can we find that antiderivative? Yeah, super easy. I just distributed the 5 through. So I got 1/2 times, now let's take the antiderivative. What's the antiderivative of u to the 6th? What's the antiderivative of 2u to the 5th? Plus a constant. Distribute my 1/2, and what do I plug in for u? X squared plus 2. So I got x squared plus 2 to the 7th over 14 minus x squared plus 6, or plus x squared plus 2 to the 6th over 6 plus a constant. The 2's canceled. And that's the antiderivative. We found it. It's a tricky one, but we got it. Go get some brain food. Come on back. Those tags and everything. So, all right, here we go. Let's try next one. Okay. What do you think u is? X cubed minus 4. So what's du? So what I'm going to do is I'm going to divide by 3. I'm going to multiply by 4. In other words, multiply by 4/3. So 4/3 du is equal to 4x squared dx. I got my 4/3 du in there. What does that take care of? So I'm going to rewrite this x to the 5th as x squared times x to the 3rd, right? So I've just gotten rid of the 4. I've gotten rid of x squared. I've gotten rid of dx. What can I put in place of the x to the 3rd minus 4 to the 3rd? U to the 3rd. Now I need an x to the 3rd. U plus 4 is x to the 3rd. I use that. I call this a double substitution. All of a sudden, it's no big deal. So I have 4/3 times the integral, u to the 4th. Oh. Integral, u to the 4th plus 4u cubed du. Time now to take the antiderivative. And so this is what's important, folks. I know I don't want to get too technical with the terminology, but you want to continue to write this integral symbol in the du because you haven't taken the antiderivative yet. Then when you take the antiderivative, it goes away. So I get 4/3 times u to the what? Over 5 plus u to the 4th plus a constant. Now I'll distribute the 4/3 and I'll place x minus 4 back in. 4 times x minus 4 to the 5th over 15 plus, yes, thank you, x cubed. I have my, there we go. I was looking at that and the 3 got cut off there. X cubed minus 4 to the 4th over 3 plus a constant. And again, kind of remarkable to look at our result and to understand that it is, that's, if we take the derivative of that, somehow it factors to this piece right here. It's kind of fun to actually do that if you sit down and take that derivative, go through the factoring process, see if you can get it to work out. So if you're bored this weekend, go ahead. Okay, well, good for you. Let's try one more level 3 problem. We'll try a 4th level problem and see where you're at. This one looks challenging. It's not too bad, but you got to see the trick. I would say that most people really struggle with this one, though, to see the trick. Okay, and even after I show it to you, you fail to recognize as we move forward. But let's start and see where you're at. What do you think u is? It is cosecant of x. And here's where people start to struggle. They forget what the derivative of cosecant is. What is du? Okay, Andrew knew that. I wonder how many of the rest of you knew that. Okay, good. So you just forgot the negative? Well, that's a good question. If you choose u to be cotangent, the derivative is cotangent or is a cosecant squared, negative cosecant squared, and we're still left with a cosecant to the squared then. But if I have cosecant, I come up with a cotangent. But the problem is here, I came up with more than I wanted to, didn't I? Like, I get negative du is equal to cosecant of x cotangent of x dx. No, we can't put the x over on the other side. We can't. We need to have just u's by them together and x's together. And so here's the trick. Good. So I'm just going to rewrite the integral like that. So now if I do the integral, and I put a negative sign in front, and I put a du on the end, what does that take care of? Takes care of this, right? So just that separation helps me to come up with that extra cosecant that I needed. And what am I left with? Well, now that's super easy. What's the antiderivative u to the 3rd? So I have u to the 4th over 4. It's negative plus c. And u is cosecant, so the answer is negative cosecant of x to the 4th power divided by 4 plus some constant. The du goes away when you take the antiderivative. What do you think? Last one. You know what, though? That's a great time to come on in and get some help, because otherwise it's like this. It's It's like a blue car door that's got some rust at the bottom. And then what you do is you just quick patch that up right before the test. But over time, it just pops right back up. That's called working through the mountain of confusion early on, and not just right before the test. Oh, you guys are nuts. All right. Yes, I have. U is what? 3 minus x. So what is du? Negative dx. I don't have a negative dx. Move what? Okay, negative du equal to dx. How about this, Jazz? Let's come up with a 3, okay? So how about negative 3 du is equal to 3 dx? Can we agree with that? Okay. So let's see what we got. I've got an integral. I've got a negative 3. And I've got a du. What does that get rid of? Gets rid of the 3. Gets rid of the dx. And the 3 minus x becomes u, right? Yeah, u to the negative 1/4. But what do I got to come up with? I come up with x squared. Right? Pretty cool, huh? Traditionally, calculus, we say calculus 1, calculus 2, and then we say calculus 3 is multivariable calculus. Some people say calculus 4 would be like a differential equations type course. That's often built into Calc 2 now. Then they have what they call complex calculus, which is more of an analysis course. But some people may say there's as many as say like 5 calculuses or 6 calculuses. Really, traditionally now we say that there's really 3. But analytical calculus. All right. All right, here we go. Negative 3 times the integral. I've got to handle this. I've got to deal with this u to the 1/4 in the denominator. I'm going to divide it in. I've got u squared, which is 8 over 4. So what is u to the 8 over 4 divided by u to the 1 over 4? U to the 7 over 4. This is 6u to the 4 over 4. What is negative 6u over u to the 1/4? Negative 6 u to the 3 over 4. And then this is 9 over u to the 1/4, which is just 9u to the negative 1/4 du. So we have not taken an antiderivative yet, which is where people get in trouble. If you on your test don't write the integral symbol anymore at this point, I'm assuming that you've tried to take the antiderivative. And people get confused. I haven't taken the antiderivative yet. So I have negative 3 times, what's the antiderivative of u to the 7/4? U to the 11/4 divided by 11/4 or multiplied by 4/11 minus 6u to the 7/4 divided by 7/4 or multiplied by 4/7 plus 9u to the 3/4 divided by or multiplied by 4/3 plus c. Okay, we'll substitute u back in. What is u? It's 3 minus x, and I got multiplied by negative 3. So I get a negative 12 times 3 minus x to the 11/4 over 11. plus, let's see, 6 times 4 is 24 times 3 is 72, and it'll turn positive. So 72 times 3 minus x to the 7/4 over 7 minus the 3's cancel 36. 3 minus x to the 3/4 plus a constant. And I know you're going to hate hearing this, but that is completely a viable question for your test. And in the end, to be able to look at this and say, when you take this derivative, you come up with this thing at the beginning. Pretty incredible that that works out that way. And then we were able to solve it. Okay, thank you. So Jake, you can appreciate that. That taking this derivative, you somehow get that. That's ridiculous. No new assignment, but now you can finish everything. It is all posted online for an answer key. I encourage you to get to work. You have 3 assignments so far. You get 1 more before your test. And again, we will not test on Thursday. The plan is to test Friday. If you want a study guide early, I'm going to try to run copy 7th hour. Otherwise, you'll get it on Tuesday.